Hans Fangur. I'm a professor of computational modeling at the University of Southampton in the United Kingdom and leading the data analysis group at the European Exfil in Germany. As part of Panosk, I'm leading the work package on data analysis services. And the idea there is that in addition to providing open data, we want to make that data useful and allow people to investigate the data. And our main ambition there is to provide, together with the data, software that allows you to open up this data and look inside and try to extract some meaningful entity. And so we're trying to find ways of doing that work across the different photon and neutron facilities that are partners in Panosk. The OSCOVIDA site, our open science COVID-19 tracker, fulfills multiple roles. In the current difficult situation with the coronavirus, we hope that it is actually useful to people, and I can comment on that a bit later. But it's also a showcase for this approach of open science, because we make available the data, which in fact we take from other sources, from the Johns Hopkins University and the Robert Koch Institute in Germany and other places. But what we also make available is the software that processes the data and creates the plots that we show on this webpage. So it is truly open science. It is reusable in that everything is provided together. It makes fully transparent what we do. So if anybody questions how do you get to this plot, they can look at the source code and they can see exactly the equations behind it. It still requires some expert knowledge, but at least the information is there. The people with the right technical skills can take that software and immediately build on it. They don't need to reinvent the wheel. They can use it or maybe change it a little bit. And this is the reusability that comes from the FAIR data idea. It's immediately reusable. In this particular case, we're using a technology called the Jupyter Notebook. And that means that we can show a page with plots on this OSCOVIDA side, and for people who are interested, they can click a button and they can get into a virtual compute environment in which they can create the same plots, or they can do minor modifications, or with the right skills, also major modifications. You should now be able to see my screen. This is the OSCOVIDA homepage, and we can select the country we're interested in. So let's go for Italy, which is already on the screen, but we can also use this search list. And here are some plots that show the time development. So on the x-axis, we have the time of infections and deaths. And this has been created using the Jupyter Notebook. So there are a number of interesting things to see here that we can discuss. This plot, for example, shows the daily new infections. And we can see that as a function of time, they're nicely decreasing, which is very good news. And we can also see down here, this green line, this is this reproduction number R that is often talked about, that needs to be smaller than 1 to keep the number of new infections decreasing. And it is around 0.8 according to our estimate, which is really very good news. Of course, it was bigger earlier. We can look how it has been created, and you see these cells here. These are the signatures of the Jupyter Notebook, the number 1 and 2. And I've got a button here, which I will click now. It says execute this Jupyter Notebook using my binder, a server in the cloud. We have now started this notebook in this compute environment, and you can see this blue bar. I can control that with my cursor, and I can in fact execute the code that is already in this notebook. When I press Shift Return, I'm executing the button, and in fact it's now recomputing the same plot that we had before. So I have already recreated those plots from the raw data, and that is potentially useful because I can use that to explore the data further. For example, we have a variable called cases. This shows the infections as a function of time. It's a long list here, and I can create a plot of those. These are the cumulative infections, so every day we get new ones added to that. If we want to see the daily infections, we can take the difference from one day to the next and then plot that. maybe what would be nicer is to plot bars. So here we can see the infections increasing. There was the peak, and now they're going down as a function of time, because this is just for exploration, but it gives you some idea of the ability to inspect that data with very little effort. If, for example, I only want to see data from a particular range, so for example, say from the 1st of April to the 1st of May, then I can put that date in here in the right format and try to run the same command on that reduced data set. And now you can see for the month of April how the infections decrease, as we discussed before. And now we can also read the date labels. So I'm hoping that demonstrates how there is the data, but we also provide the software to inspect it, and this Jupyter environment that makes it relatively easy to interactively learn more about this data. In this particular case of the pandemic, what seems important is the time development of things. The question is, how many cases did we have this week more than we had last week? How do things develop? Is it going up or is it going down? Do we get a handle on this pandemic or not? And sometimes we find that the media is reporting single numbers, which can be quite misleading. So let me try to share my screen and show you one or two examples of data of Russia. So here we have the number of new infections per day. And I wouldn't be surprised if somewhere in the news we can read every day the numbers are getting higher. That is correct. However, if we look at the shape of this, we can see that the rate with which they get higher is slowing down, and that is really important. So it is about the context of these numbers, and often that is not conveyed so clearly. There was a particular example where in an article it was reported that the numbers in Germany would be increasing, and they were referring to this and this day. So 27th, 28th and 29th of April. They said the authorities don't know what's happening. But if you put this in context and we plot the whole time development, which is done here, then the 3 days in question are these tiny peaks down here. And in fact, what happens is that there's a periodic oscillation in here, which reflects the working week. So during the weekend and just after the weekend, fewer cases are reported. So what really happens is that overall, the number of new infections go down, and within that we have these tiny oscillations. But by not looking at the whole story, we end up with a headline that says numbers are going up, government doesn't know what to do. That may be true, but it may also cause unnecessary panic, or maybe it's used to sell more newspapers. And these kind of questions we hope we can help to resolve with this citizen science project that allows you to look at the data in context and explore it further yourself if you want to. In terms of usefulness for people using the site, we hope that it allows people to understand what is the current situation with coronavirus infections and deaths, and to better understand the time development of the situation, to better understand why there may be restrictions in place, but also to see that those restrictions work or don't work, and therefore motivate people to stay active with social distancing.